All right, it's 10:16, so we're going to try to get started here. It's the last day, so the sort of last sprint to the finish. My name is Chris Linus. I'm from NASA. I've been working at ESIP for a few years now. And it's been really useful as a place to bring different communities together, and particularly different bases of knowledge together. And what we're going to be talking about today is actually another sort of layer of bringing those knowledge bases together. This is basically a session about how to connect data with the usage that's made of that data. And I started this off with a kind of a geeky, it's a graph approach, yada, yada, yada. But really the important thing is making those connections between the data and the data usage. And in fact, if we want to put that into the context of the overall ESIP, this is, ESIP is making data matter. And essentially what we are doing by documenting these links between data and data usage is documenting how data matter. So at least in my mind, this activity could be fundamental to the most basic values of ESIP. And so I want us to sort of think in those terms. Now, some of you in here are, graph and RDF geeks, and you're going to know all of these sort of detailed graph stuff. Some of you are not. But what we're looking for is not just that, how do we connect these different knowledge bases together into a massive knowledge graph, but also what are the possible use cases for this? This, again, think of it as just connecting data with the usage that's made of data. I know we have some basic data discovery use cases. We've got some impact metric use cases, but I'm also interested in getting you in the audience, particularly those of you who are not down in the weeds, to think about additional use cases. One of the things that came out in one of our geeky sessions yesterday, where we were making knowledge graphs, is that it's not a good idea to just say, knowledge graphs are cool, let's go make one. You really need to have some idea of how you're going to use those in order to make an effective one. And so with that, we're going to have several talks, and they will be at different levels. Don't worry about that. If it gets too geeky, just sit back and start thinking about your use cases, because at the end, I'm going to start, asking the audience to see if we have any additional use cases to the ones that have been discussed in this meeting. So with that, I'd like to bring up Doug Newman from NASA. He's a system architect at EOS-DIS, and he's going to be talking about what we were doing within the EOS-DIS knowledge graph. Does presenter view work here? Yes.
Hi. So just about every session I've been into this week has mentioned graph in some case. And it's become apparent to me that, as Chris mentioned, that some of us are more in the weeds than others. I'm not as in the weeds as I thought I was. Having said that, here's my talk. So I'm going to talk about our first dipping our toe into the waters of knowledge graph. Decided to tackle this as a prototype and take sources of knowledge that we within ESDIS have and marry them with some external sources and evaluate various technologies through that. So we're testing against in-house entities and association, and branch out to things like missions and instruments that have their canonical source in something like the CEOS database, and essential climate variables, which are governed by the WMO. So we looked at various implementations of graph and APIs associated with that. The implementations we looked at were Neo4j, which is generally the first port of call for graph. They have a free community edition. Anybody who's had a look at this stuff has probably looked at Neo4j. And then AWS managed graph database solution, Neptune. And the APIs that we looked at were two standards-based APIs that are out there: Sparkle, which was well known within this community, Gremlin, an Apache project, and Neo4j's default API, Cypher, which is, I think, soon to become a standard in GQL. So What we did choose in the end was, after prototype research, was AWS Neptune and Gremlin. We chose Neptune because it supported two widely accepted standards, Sparkle and Gremlin, as I mentioned earlier, out of the box. And it fits nicely into NASA ED's existing AWS ecosystem. It gives us a managed service for graph in Neptune. From an API standpoint, I selected Gremlin because it seemed the most intuitive graph API of the three, and it's implemented in a large number of languages. So that's really an engineer's perspective on it as opposed to a scientist. I know the scientists are heavily invested in Sparkle at the moment. So we kicked off with creating a graph from CMR entities that we had in-house. The obvious one is Datasets. Then we looked at documentation, and the reason we did that was some of my research indicated that scientific literature can often cite the documentation associated with the dataset rather than the dataset itself. And the holy grail that I was looking at the beginning of this was getting associations between scientific literature and a data set. So somebody can take a scientific paper and figure out what data was used to create that work. But after building that graph, I had a bit of a light bulb moment. Not so much in the fact that I noticed that a lot of data sets share documentation. That was quite obvious to me. It was working in CMR for like a decade. But how easy it is to traverse that relationship using a graph implementation. You can see a JavaScript Gremlin query on the right-hand side here, which basically says, given a particular data set, let me navigate out and traverse the edges of all the documentation that's associated with that, get to that documentation and navigate back out to other data sets. And it seemed to me that that was a good way of determining a recommendation based on data set A, what other data sets were similar to that. So for S3TM in this example, its documentation is shared by about a dozen other data sets. And it was really trivial, like 4 hours of work based on that query, to stand up a recommendation engine in a web-based application to say, you've selected this data set, these other data sets are probably of interest to you as well. And that got me thinking, once I've got that initial scaffolding, we can then reinforce those associations by user traversal of those associations. That if a user was searching for a particular data set and then they migrated to another and actually acquired something associated with that other data set, then we can increase the weighting of that relationship there based on the usage of it. So after that, I took a bit of a pivot and started looking at external entities that we would want to associate with. And the first one I looked at there was essential climate variables. This seems quite a tangible use case that somebody would use one of those essential climate variables as a starting point for their discovery journey. I want total ozone data, for example. So there are 496 products associated with the climate in the essential climate variable suite. They're spread across 30 variables and 3 domains. And we have 425 of data sets within CMR currently mapped to one or more of those products. So here's a graph of essential climate variables. You can see we've started at atmosphere, that dark blue blob there. And then we have the associations of all the, what am I looking for? What do they call it? Variables. I always forget that intermediary step. And associated with those variables are actual products. So you could see that we've gone from atmospheric ECVs on that domain in the center there, out to precursors supporting the ozone and aerosol ECVs, and then up to a carbon monoxide tropospheric profile. And we've managed to put that link into a particular data set, and you can navigate through that very easily and find a data set that you want if you're interested in CO tropospheric profile. The next use case we looked at was missions and instruments. The canonical representation of those is in the CEOS database. We have linkage between these three entities, missions, instruments, and datasets within CMR, but we don't have that canonical representation. So we built another graph there, and you can see this is the CBERS 2 mission and the instruments associated with that, and the datasets are also related to that mission. And we have concrete links to that canonical representation of those things. And in some cases we have DOIs, some cases we don't. A more concrete representation would be better, obviously. And finally, we looked at another in-house thing. CMR, well, EED holds the GCMD, which curates science keywords, and that seems a natural fit for a graph representation and the linkage between those science keywords at various levels and data sets that are resident in CMR. So my main conclusion from this is that me, as somebody who is not an expert in this field, not an expert in this science, it took me 10 minutes to looking at visualizations of associations between data sets and documentations to come up with a recommendation engine, and another 4 hours to actually implement that, which makes me think that graph technologies and APIs are highly suited to this kind of discovery challenge. And providing a traversal API over that knowledge base, which other people with more knowledge than I have can exploit, can possibly open the floodgates for some very novel discovery techniques. So what are we looking at next? I want help. I was looking at CEOS database, ECVs from WMO, and there's no uniform way of extracting that information. I actually resorted to HTML scraping for the CEOS database. Obviously, that's not a way forward. So getting help from these various entities and entities like yourself in putting together this knowledge base is where we need to go next. You want to save questions to the end?
No, let's take 1 or 2 questions now.
Mike here, and please raise your hand because it's a hard room to run around in.
I'll bring up the other one while you're doing that.
So this is the guy who did the plenary dimension graph. He's one of the experts, right?
No, you're the expert. Hi, thank you very much. Excellent presentation. You're the expert in traversing using proxies like variables and documentations. That's brilliant. What I'm curious about is, did you stand that up as a web service somewhere where we can hit it and try
that it? That is our next step. This was done in a small and a prototypical fashion. It's sitting on a laptop. Oh, sorry, it's not a laptop. It's sitting in a sandbox environment on AWS, but it's not open to the public yet. But we envisage using this for some in-house association use cases we have in CMR and then branching it out into this. So not yet, but hopefully soon.
More questions?
All right, well, let's go into the next talk. So one of the sort of very early examples, I think, of connecting data with data usage has been the Global Change Information System. They've been real pioneers, at least within our public sector sector. And so Reed Sherman from GCIS is going to talk about how they've been connecting data with the usage with respect to climate assessments rather.
So just so I have a sense, how many people here are familiar with the National Climate Assessment? Okay, almost everyone. And how many people are familiar with the Global Change Information System? Okay, great. So I can go through the first half of this very quickly to get to a little more of the meat of this. So really with the Global Change Information System, when I read the abstract of this session about connecting data with data usage, we're really trying to do that in 2 ways. One is thinking of the National Climate Assessment or other scientific assessments as a use of data, and we're connecting the data that was used to do, to make that assessment with the assessment itself as the use, but also enabling other connections of data to data usage by making all those connections really transparent and open. we can get users to, and readers and stakeholders for these assessments to have a much easier time connecting their intended use with the data that would be good for them to use for it. And so by providing this traceable provenance so that people can find the connections between the assessment and the data that was used for it, we do it for sort of three main reasons, which increasing the credibility of the report, enabling reproducibility, which is sort of the key thing that we talk about a lot at ESIP, and then to inform decisions, as I said, to let other people connect their intended use with the data that would support it. And so we surface the information sources and those connections in sort of three ways through the National Climate Assessment. The first is through what's called traceable accounts. The second is that citations are really traceable and navigatable for people reading the report. And the third, which I'll talk about the most, is that figures have their data and processes documented, well documented, and openly accessible. So the first one, for any chapter of the report, there's you have all the scientific content of it, and at the end you have something called a traceable account, which is basically a detailed description of the process used to write the chapter. Where did how did they decide what their conclusions were? How did they what was the evidence base? What were all what are the major uncertainties? How did they decide how certain they were about the conclusions in the report? And so having all that information and connecting it together with all those sources is one way of connecting data with data use. The second is that citations in the report. So if you look at some piece of prose, there are a lot of footnotes, and if you click on any one, when you're looking at the website, it instantly pops up the citation with the information about it, including a DOI, and the vast majority of our citations in the National Climate Assessment have DOIs, making them really persistent and also easy to navigate and get to the source of. Now, many of these DOIs will lead to a journal where the articles may be behind a paywall, but at least it's open and traceable to get there. And behind the scenes in GCIS, we have a lot of extra information beyond that, one-line citation about what goes into those, what's part of that source. That we have the authors and institutions documented, and the information about the journal it came from. You see all those things are hyperlinks, so you can get to records about those parts of the citation. And then the third way that we're connecting is through figures, so that if you look at any figure in the National Climate Assessment, you see there's a little icon in the upper right of an eyeball, and that takes you to a whole metadata record that talks about the data set that was used for that, and goes through the whole process. So we capture something that we call an activity, which is basically a description of how the person who made that figure took the data set and made what you see in the assessment, so that other people can do the same thing. And that there have been cases of news organizations, for instance, or other scientists as well, using this record to then make their own visualization or description about about climate change and impacts, so that they don't just have to copy the exact thing of what's in the report, but really seeing the fundamental understanding of what ended up in the report. And so, digging in a little bit into the weeds, the way that we structure this information in GCIS, we have semantic connections in our database, and we sort of connect data and data use, and those two things described very broadly in two ways. We have that a publication can cite another publication, so that's one use of that information, and cites being a semantic link, or the other is that a publication can be derived from another publication using an activity. So there's a sort of third piece there. And publication here can be a lot of different things. It could be your report, like the National Climate Assessment. It could be a chapter of that report, a figure of that report, or an article from a journal, a data set, a book. There are a lot of different kinds of things that can be a publication. So a figure, say, could be derived from some existing article, where an author has done some scientific work, and then we want to use that. Or it could be derived from a data set used, and then the activity is the description of how that was done. So I want to show another sort of visual representation of how all these connections are in GCIS. And it's a little bit small because we have a lot of different things in it, and this is even somewhat incomplete. But on the left side is sort of a visual representation of the information that we capture in GCIS. At the top, you have the National Climate Assessment, and you have pieces of it going down like chapter and figure. And they connect then to references, to findings, to articles, and those articles will connect to journals. And if you see those little icons, each of those pieces will have authors and institutions that made those. And so you can sort of follow this chain in a lot of different ways, all the way down to the bottom, where you have an activity in a data set that created some image that you see. And on the right, there is just sort of the standards that we follow to do this, that we try to meet fair metadata principles, and we use a lot of existing standards and databases so that we're not inventing our own structures a lot of the time. We can use existing standards like ORCIDs and DOIs and so forth. And then our output is in a number of data formats useful for people to do. Now, this simple idea of connecting through citations and through derivations from sources to use can really follow way beyond just the provenance of our assessments. And I just want to mention the limits of what we're capturing, that are not limits of our model, but just limits of the content of what we can do. And that's that if you look at some result in the National Climate Assessment, whether it's a finding or a figure or a table or whatever, it can come from a number of different places. And a data set comes from an organization, but a data set also comes from, can be derived from an instrument or use an instrument. And it has different versions of that data. And the dark thing, the ones shaded dark are the ones that were sort of not so complete in what we're trying to, in what we're able to capture. Similarly, as I said, a figure could be derived from an article, but that article, that figure in that article could be derived further from some data set. And we don't sort of dig beyond the source of what we're citing to say, well, what did they use? And then what did those people use? And just because we can only do so much work. But those connections exist in nature and could be sort of incorporated into part of this full connection from fundamental data all the way to data use. And so I wanted to, I think I have 1 minute left. So I want to quickly just say the kinds of things that we're thinking about and improving for the next time. There'll be a 5th National Climate Assessment in a few years. And the kind of things we want to do are to improve. There was a session a couple of days ago, which some of you may have been at, talking about metadata evaluation. And Amrutha, who's on the GCIS team, talked about the metrics that we're developing. And so we're improving those over time to really assess our quality and our prioritization of what we need to do to make this system useful. The second is just, all this information has to come from somebody's effort. Some of it is ours, a lot of it is the authors of the report, and improving the way that the authors interact with submitting their metadata, collecting the metadata of what they did, so that can be a smoother process, especially around the activities, the process of creating things. The third is implementing navigation through topical keywords. So you already heard a mention of GCMD keywords, and we're implementing GCMD keywords to describe the records in our system, so that you could see that this figure has to do with is tagged with some keyword. This result over here is tagged with some keyword, and having that be more fully integrated so that a user of the report can navigate through the report by topic. One thing that USGCRP is working on is something called Derived Products, where if you look at the National Climate Assessment, it's hundreds and hundreds of pages long. But if you're interested in, say, fish, it turns out there are statements about fish in 23 of the 30 chapters, and a whole bunch of different places. And so if you were interested in that, it would be really hard to find what you need looking through the report. And so what we have people who are basically reading the report, pulling out all those statements and arranging them into a new publication. But the more we do by using GCMD keywords to tag concepts in the report, the more that can be done sort of automatically by just saying like, where are all those tags, pull them together to pull out things by topic and find things that you wouldn't find just by reading a chapter in isolation. And then finally, we're always improving our data modeling technology, adding new concepts, more semantic connections to connect versions of things, or a data set with a previous version or a report with a previous edition, and so forth. So I just want to acknowledge the rest of my team and also the team in Asheville, North Carolina, working for the North Carolina Institute for Climate Studies, which really does a lot of the information collection for us from the authors, and really couldn't do this without all of them. That's it. Thank you.
Hello. So I wanted to, I was following your work from previous years, so I'm interested to hear your updates. And one of the things that interests me is the concept of master metadata. So you have a business process, you're trying to support the climate assessment, and you have to basically follow and make broadly available your highly shareable information. But there's a secondary use here, the fishermen or the people who are interested in fish, how that concept's used across the report. So that's not part of your core use case, but something you'd like to support. So I think it's possible and interesting to use keywords and tagging, but I think there's also ability to use secondary or different kinds of knowledge graphs to support these other use cases explicitly, bringing that out, those different use cases out as different parts of the GCIS. So I guess I'm making a comment. Have you thought about expanding your model and making it more accessible as a community model for people to mine?
Somewhat, and also I think another thing that we always look for, especially through through ESIP and such, is to connect our use case and model with people thinking of other use cases that can sort of meld together technologies and use cases to make it more more universally applicable. So that there's only a limited amount we'll be able to do with our team, but wanting to make sure that our team connects with people attacking that problem from different angles.
Right. So I think, for instance, the phenomenon that Doug noticed in the previous talk, where this association suddenly sort of appeared, and we said, "Oh, that's a useful association. That might be useful in your special topic case."
Right.
That would go beyond just the keyword. Is that essentially what you're suggesting? That? Yeah. In fact, I think we've also seen that if we get the people that are involved in these products and data sets in there, we can also see nexuses there, because a lot of times what we're looking for is we say, oh, I want so-and-so's data product. And that's how we associate that. And so there might be some aspect of that, because really all of this knowledge comes from people. It's resonant in people. And so I think we might actually see some things come out of that if we can identify the people associated with publications and figures. And you have all that in your database. So that's a good comment. Thank you. Any other questions or comments? All right.
To lead into my talk, actually, I saw Mapbox on your W3C kind of linked data. What are you using from Mapbox?
I'm not actually the best to answer that question, but I'll connect you with.
All right, so actually federating these very different knowledge bases can be a somewhat daunting task. And the reason that I know that is because I've been watching Dave Blodgett essentially, corral all of the stuff that's going on and into the environmental linked features experiment, interoperability experiment. This is something that's happening in the OGC framework, and we're going to talk about the second version of that.
All right, thanks. Thanks for the invite. And this is going to be a little bit different. So for those of you that aren't familiar with the interoperability experiment paradigm, it's a volunteer OGC governed process where basically a group of the coalition of the willing get together to run some kind of experiment on new and emerging technology for use cases they care about, which is exactly what we're up to. So this talk is a little bit different than the previous ones, but I think it fits in this session in that we want to be able to track research and data about places just as much as we want to track research and data in general and how that all relates. It's very important to connect our research and data to place. And the big gap that we are basically observing is that there's very little practice around kind of using place identifiers in our linked data, and actually really embedding the concept of place in a consistent way is just not done commonly. So, okay, so in the first ELFI, we really focused on content. So linked data content, what actual knowledge do we want to be handling here for these use cases? And we kind of came up with three kinds of content, three layers or views, if you will. One around a search preview, one around kind of the topological network of a place and the data related to it, and then one around more or less the application domain, so groundwater, surface water, wells, geoscience, the application domain content knowledge that you might want to encode. We landed on using JSON-LD, largely inspired by kind of the prevalence of schema.org, JSON-LD markup in kind of web search crawler usage. And then it's really important to point out that we were constantly focused on rooting this in kind of webby W3C best practices, but adhering to the kind of core standards and best practices from the Open Geospatial Consortium, IETF, IANA, these kinds of places, just to make sure we don't lose track of kind of that rigor that is what really makes all this scale. Okay, so coming out of this, we found this all looks pretty promising. We've got some ideas that we think we can carry forward, and we need to do future work on basically how to discover this content. And we have this basic problem that we want to solve, which is that the data we're working with is inherently multi-provider, right? But the real world is inherently like single valued. A place should only have one identifier, and you should be able to go to that identifier and find all the information about it from some place. And this is the role of Google typically, and I think in our dream world that Google would pick up on all this information and have a knowledge panel that's representative of the data for a place, right? But we need to get there, and we also need to have communities of practice around this that are going to have the domain knowledge that Google is not going to put in their index, right? So I'm going to move a little bit quickly here. That was basically we wanted to evaluate a resource model in the sense of a uniform resource locator, the actual resources that you would get back from a URL. We have a number of kind of things in motion around OGC API, around content negotiation by profile, et cetera, that we wanted to start to look at. So the way that I'm kind of alluding to this, but to this on the screen is essentially supposed to demonstrate we want to be able to go from the web portal that is the search infrastructure to a landing page that basically spiders you out to all the data about a place, right? And then actually go find precisely the data you're interested in, whether it's HTML, GeoJSON, JSON-LD, RDF, et cetera, right? All that needs to be documented in a fairly coherent knowledge graph. So the project has 4 and a few more, if you dig into the details, technical applications or teams that are taking part in the interoperability experiment. One that I'm very close to is this US-Canada cross-border linked data hydro kind of pilot that some people call it GSIP, other people call it child. Anyways, it's an interesting application that we've heard a little bit about this week. There's some work going on in Australia around different groups that hold information about the same borehole. So a well that has been drilled, multiple groups have surveyed it or have looked at the core and have information about that borehole. There's some environmental monitoring data kind of across multiple providers from New Zealand. And then there's also somebody from BRGM in France that's working with kind of linked hydro data, surface water, groundwater relationships in the EU and Inspire kind of context. So we're working with people in a lot of different places and a lot of different kinds of use cases, which has been frustrating at times, but I think it's important that we take into account this kind of breadth of systems and technologies and use cases if this is really going to be workable going forward. So one of the biggest kind of hurdles we had was just understanding the problem. And we kept feeling like, oh, we could scope this project up. Oh, wait, no, we actually understand the problem better. We need to scale back. We understand the problem better. Oh, we need to scale back. So where we really started was with HTTP range 14, which if you're not familiar with it, I don't have time to go into it, but essentially it says a real world thing can be identified by a URI, but you can't get the real world thing through your screen. So we need to do something else, right? We need to make another hop to a digital artifact about the real world thing. And we've had good experience with that. And we think there's a business case to pursue using 303 redirection a la DOIs, but for real world things, not digital objects. This issue of information resource content variation, if you will. So I don't want that view of the metadata. I want this other view of the metadata, or I don't want that representation of the feature. I want this other representation of the feature. This is a sticky issue. And I really like this quote. The problem with metadata is it's always relevant, but how much and which metadata depends on the use case, right? Which metadata profile do you want? Well, it's the same resource. It's a metadata resource. How do we select it? This is going to continue to be a sticky issue. We've made some progress, but it's going to be hard. And then this issue of cross-organization network architecture. How do the nodes of linked data fit together at their edges? How do they talk to each other? How do they harvest each other? How do they crawl each other? We've also made a little bit of progress on this, but this is going to need to be future work as well. Okay, so what we've come up with is essentially you've got your real world identifiers, we call them non-information resources. Those are URIs. 303 redirect to some landing content. It's going to be a default view that is essentially the stuff you want to show to a search engine, and a way to discover all the additional information that some linked data node has. And given my time, I'm just going to keep moving. If you want to hear more, this is all kind of in the finishing stages, and we're starting an engineering report. So what's next? We're wrapping this up, and this is really to say what we as a community need to start doing to support these use cases. We need to identify some URI resolvers for real world entities, and start to get behind those as a community. You know, DOI has momentum. We don't have a DOI type system for real world places. There are a number of examples that are trying to go there, but don't see themselves as the resolver for real world places. And I think there's a need for that. We need to establish more instances of what we mean by this landing page or this meta content. What is a place-based landing page that gets you to information about that place? Gets you to data about that place. We need more examples so people can copy success, copy what's good. And we're definitely going to be doing that as part of Selfie, and giving people examples to follow. And there's lots of future work here at ESIP. There's interesting work going on at OGC around the OGC API. It fits very nicely into this. And you know, the spatial data on the web and various other data exchange working group kind of activities at W3C are looking really promising. So I'll stop there. Glossed over a number of things, but given time, I think that was probably a decent coverage. If you want to find more information, you'll find us at Selfie OGC. You can follow us on GitHub. Everything's being done kind of out in the open on a GitHub issue tracker. And you can contact me, dblodge@usgs.gov. So.
Thanks, Dave. Are there any questions? actually have a quick
Okay.
question. So you guys are tackling space, which, to tell you the truth, I never properly appreciated until I saw this talk after Doug's talk, that we need to somehow tackle space in what we're doing too. But have you thought about whether you need to tackle time? Or is everything kind of in the present so you don't have to worry about it?
So yes, there's a JSON LD context that we've come up with from Elfie and now is part of Selfie for the topology, and that's both spatial and temporal topology. And I would say while we are inherently using spatial things, they're features. They're features, and they should and could have a temporal kind of attribute just as much as a spatial attribute. So, but yeah, I mean, so storms, for example, emergency events kind of things, those were in scope for a lot of our conversations.
Okay,
so
thanks.
Yep.
All right. So the idea for this session actually came to me when I went to the Pecora conference in Baltimore in October. And I saw a couple of talks in a session that I just sort of happened across that I thought, oh, that's very similar to what we're trying to do with the knowledge graph aspect and connecting data with data usage. And so I've asked representatives of the people that gave those talks. I think in each case, we've actually got another person talking here, but to essentially talk about those use cases for connecting data and data usage, which sort of fall into the strategic aspect of things. Okay, that's you. Okay, so the first talk is going to be by Joe Conran from NOAA.
Contractor too.
Contractor too.
Legal.
Okay.
Make sure I don't get in trouble. Hi, once again, I'm Technology Planning Integration for Observation Division. I'll be presenting on analysis we employ to connect civil agency data requirements to NOAA satellite instruments in the societal benefit area these satellites and agencies support. Essentially, it's an application of directional data that we use to solve a policy problem. I apologize for the textbook slide. You can throw a bagel or coffee or something at me if it gets too boring. Just to provide a little background, in 2013, Congress directed the White House Office of Science and Technology Policy to establish a mechanism to ensure greater coordination of research, operations, and activities related to civilian Earth observations. To fulfill this, OSTP created USGEO, and they tasked NASA to lead the Satellite Needs Working Group to identify U.S. civil agency Earth observation requirements to inform satellite architecture, future planning and development. In spring of 2019, NOAA completed the second round, or a review of the second round of the Satellite Needs Working Group. We looked at 78 civil agency requirements and identified which needs could be fulfilled through NOAA satellite instruments. Using WMO's OSCAR, or Observing System Capability Analysis and Review tool, which I've linked below, I guess, if you want to click up on it. We identified different features such as channel resolution, data latency, and other things to see which ones we could fulfill. We found that 29 of the 67 non-NOAA satellite needs could be fulfilled. The primary limitation being spatial resolution. Once we finished the core analysis, we wanted to verify our findings to identify ways in which NOAA currently serves other civil agencies. And to do this, we leveraged another USGEO effort called the Earth Observation Assessment, focusing primarily on MODIS users that could find merit in both Sentinel and VIIRS imagers. To give a little background, this is the Earth Observation Assessment. It was created to establish a mechanism to ensure greater coordination of Earth observations. It provides a relational framework of observing systems relied upon to meet key Earth observing objectives. And so essentially this is the relational directional thing. It goes, I guess for people online, I'll talk over here. It goes data source to product service outcome, agency owner, objective, societal benefit area, and sub-area. And below are different societal benefit areas, which include agriculture, biodiversity, things like human health, energy and mineral resources, transportation, water resources, weather, or reference measurements, just to name a few. This is an example of a flat Excel type data file. Here we see Aquamodus is one of an instrument on a NASA satellite going to DOI USGS, and that's serving to understand how oil spills affect marine environments. And that goes onto the societal benefit area of energy and mineral resources. And we use that to understand and mitigate environmental impacts. And the sub area to that is improve the understanding of the fate of fossil fuel resources released into the environment. This is kind of boring though. This doesn't really help if you're trying to visualize the data. So then I built a script to convert this into a kind of a node, or I guess they call it a Sankey graph, where it goes from NOAA satellite instrument to the different civil agency and finally to the societal benefit areas. I think the size of these is weighted by how many products or services each agency uses. And so what, I just wanted to show you a quick example of cross-agency collaboration and analysis using NOAA, NASA, OSTP, and USGS data. I wanted to show you that the EUA value chain exists and it provides a cross-agency view of the impact of NOAA satellite data. NOAA also has a NOAA internal value chain or relational directional database called the NOSIA, which is the NOAA Observing Systems Integrated Analysis Value Tree. And it provides more of a NOAA specific view, similar to the EOA type database. So what are the next steps? I think one of the big things we could do is going beyond the societal benefit area and really looking at the end users, because that's where the decisions are made. That's how we derive value or understand the value of various NOAA observations or Earth observations, civil agency observations in general. These are some of the 2020 efforts. So for NOAA, with the NOSIA, we're updating to collect, because I think the last time we did it was 2013. We're trying to update it to collect new satellites that have flown since then to understand how those inform our products. We're also trying to expand to look also at more economic type decisions, the external users, and how they use our products, more of the public facing products, whether they be on weather.com, things like that. USGO is also moving along. They just released the National Plan for Civil Earth Observations. There's a Satellite Needs Working Group Round 3 that will be conducting shortly. And then hopefully there will be a new Earth observation assessment coming soon. Just some more information. And if you have any questions, I'd be happy to answer them. Thank you.
John Ralph, NOAA NCE. Have you thought about trying to link to commercial sources of data? I mean, you were talking about resolution being a limiter, and some of these commercial satellites have a much higher resolution. Maybe you can.
And so we have, with the Satellite Needs Working Group, we identified that a lot of these civil agencies use commercial data to fulfill the needs. And NOAA satellites, or even some of the NASA satellites, we just don't have that resolution. And so we know it exists, but our database is NOAA-centric. It'll be a huge lift or an immense lift to identify every commercial data source. But in the future, if we had more funding, more resources, that would be a great thing to leverage. Yes, we agree. And we also work with Mike Brewer to do a lot of this stuff. Yeah, we might be down again soon.
So I guess my question would be, is it possible instead to have the commercial satellite operators themselves contribute to that kind of?
That would be great, but I mean, even as is, it's difficult to get NOAA, different divisions, different line offices to help contribute and complete our database. So I think going beyond that. And I think also there become issues with, I guess, the Paperwork Reduction Act to develop surveys to really talk to the public as well.
It's something we could do in ESIP without.
Yes, and I think that could be something we leverage, and maybe I'll talk back with our division and see how we can do that. I agree.
All right, cool.
I think there was one more. I wish we had time. I'm not sure.
No, I think we lost one of our talks.
Okay. It's up to you. Yeah. Okay. Thank you.
Wait, I have a quick
Sure.
question. So you were showing societal benefit areas, which I think is a geo construct.
Yes, it is.
Have you gotten any direction to look at the UN Sustainable Development Goals?
So I'm not OSTP or USGO in specific. I'm a NOAA analyst that uses the EO Earth observation. That would be something that we could help, or at least I think Will also is a big fan of the EOA. We can direct maybe in the future for this, if there's a new Earth observation assessment, maybe consider a different way to apply that. Within NOAA, our value chain or organizational hierarchy, we look at the line offices and then our mission areas that we try to serve based off mandates and other requirements that we have to instead of societal benefit areas. That's how we use it. Right. Yeah, I think in the future it'd be fun to show off our specific one, but I thought this is a little more fun in general.
Thanks.
Thank you.
All right, so now in a similar vein, we're gonna have a talk by Will Doan from IDA, assessing the impact of land imaging. And again, it was my seeing these two talks or similar talks at Pecora, kind of next to each other or near each other, that made me think that it would be a good idea for us to all get together to talk about this sort of thing.
Good morning. So my name is William Doan. I was not the person who gave this talk that Chris heard, but that's okay. The similarity is not at all accidental. They're all derived from the same supported efforts. I'm with IDA's Science and Technology Policy Institute. For those of you who are not familiar with it, we're an FFRDC, Federally Funded Research and Development Center, tasked with supporting OSTP. And through that, we've been supporting USGEO for a decade. USGEO and related efforts for over a decade. My colleagues, Emily Silik-Glassman and Jason Gallo, originally gave this talk last October. Because playing off of, let's see here, I'll jump around a little bit, playing off of the previous talks. So the 2016 Earth Ops assessment, which STIPI, it's a lovely acronym, Science and Technology Policy Institute, pronounced incorrectly. STIPI participated in helping design the methodology for eliciting information from subject matter experts and for cataloging that information. We conducted hundreds of subject matter expert interviews over the course of multiple years. Just as a sense of the scope of this effort, it was originally authorized a decade ago now in 2010. And various prongs of this effort have been undertaken at USGEO, NASA, USGS, and continue through the present day and hopefully far into the future. For a sense of scale of the Earth Ops effort, again, we have the 13 societal benefit areas at the top of the chart. And yes, those societal benefit areas have been playing into and off of both national and international conversations, UN conversations. The Arctic Council a couple of years ago adopted this framework as a basis for their process for evaluating Arctic data collection. The assessment was a tad Herculean. Tremendous number of people listening to a tremendous number of people, cataloging a modest number of data sources. In the end, the number of unique data sources that got referenced was 1323, a number that we worked very hard to come up with and stabilize on, but 1323, identifying the unique sources, removing all of the ambiguities that we could. Why does then any of this play into graph databases? Those 1,323 data sources, nice, small, manageable number, produced a data set that, when represented as a rectangular spreadsheet, and as a computer scientist, I apologize to the world for spreadsheets. They were easy to program. I'm sorry. Those 1,323 data sources produced a spreadsheet that was almost 150,000 rows of information. It was unmanageable. You couldn't look at any part of it and gain any deep insight into what was going on. And for us at STIPI, supporting OSTP, supporting policymakers, the core question is, what are the insights? So we were pretty far from getting the 150,000 data rows down to something that might inform policy discussions. We converted that into a graph database using, at the time, this is now 4 years ago, using relatively unsophisticated technology, but extremely stable and well-supported technology, backed by an iGraph engine. We considered Neo4j at the time. It was still a pretty limited product back then. It's since developed quite a bit, and we might well reconsider that if we undertake working on the graph aspect of this again. We managed to reduce the 150,000 rows of data down to about 55,000 nodes. And from that, come up with a number of analysis techniques that involved telling stories, creating the narratives that allowed us to trace paths from data sources to societal benefit areas, up through that value tree that was just hinted at, where you've got societal benefit areas at the top of the tree, sub areas underneath that, key objectives that come from that, key products and services that feed those key objectives, key products and services that are feeding other key products and services, data sets that go into reports that go into, et cetera. And at the bottom, ultimately, the observing systems, the platforms, and then the instruments on the platforms. I'll come back to this in just a moment. Thank you. So obviously, there are a lot of systems in play. There are a lot of systems that are doing space observations, a lot of systems that are doing land-based observations, a lot of interconnections between these systems. To challenge something that David said, the world is inherently about singular things, I think was the comment, something on that order. I didn't write it down fast enough to capture it fully. Again, as a computer scientist, I think one of the biggest sins that we have as a discipline has been teaching people how to create things that assume a one-to-one relationship, that there's a name for a thing, right? When in reality, life and the universe is multi-to-multi relationships. It's much more complicated. It's much harder to conceptualize. It's much harder, but that's the reality of it. One person has many names over the course of their lifetime. One person has many addresses, even at an instance in time. Never mind the temporal mechanics of it that came up during the last talk. So I think a lot of what we've been trying to do is to think about how these data systems, using the EOA 2016 data set, how are these data systems interrelated with one another? How are they being used together to achieve the societal benefits that, that are the core focus of the assessment? And so just to give a couple of examples of this, that will be familiar to many of you, but the idea that Landsat and MODIS data might be used together to look at imagery data in order to characterize the kinds of activities that are going on at ground level. We see this in disaster response. We see this in crops management. It's not even exceptional. If someone tells you that Landsat and MODIS are being used together, you don't think that's an unusual thing. But again, looking at a rectangular data set, it's sometimes very hard to gain the insight about which systems are being used together, how they're being used together, how often they're being used together, and what depends on them being used together. And so going back to the idea of Sankey diagrams, we've built in-house at Stippy an analytic tool that we use. We call it EOA Explorer, that's built on top of the graph database that we built from the EOA dataset. And building Sankey diagrams is just one very small niche corner feature of that. But fundamentally, the questions we're trying to answer are related to the hows and whys. How are things being used together? Why are those things being used together? What are they achieving? What benefits are they achieving? And so here we can see a number of things. Well, I can't see them because they've got the presenter version of the slides down on the screen here. But you can see a number of different data sources on the left feeding into key products and services, feeding into a report. Key objective, the active fire mapping protocols. And we see this again, using a combination of services to track fire imagery. It's essential that we be able to use these services together if what we want is a quick response, an accurate response, given the frequency with which we can scan a particular point on the surface of the Earth with one instrument. It's important that these data sets be able to work together. Similarly, other uses of the same two data sources, fire management on the one end of the spectrum, sea ice products on the other end of the spectrum, being able to support all sorts of different observations that wouldn't on the face of them necessarily be considered to be related kinds of observations. Here we have those two systems, and you can see actually three, because we've factored in both Aqua and Terra Modus on the left-hand side here. But that combination of three data systems flows through the tree, through the graph database, through the knowledge graph, through the set of key products and services, and up to the SBA sub-areas, and eventually to the SBAs. And so it's not an unusual question to say what would happen if this report were taken out of the system and no longer supported, or if this data source was taken out of the system and no longer, how would that affect the rest of the tree? Notice here that we're fundamentally concerned, for those of you who are familiar with EOA, we're fundamentally concerned at the moment with the number of ways things are connected and how they're connected and how they would be disconnected if we took something out of the system, and not, say, the impact scores that came out of the assessment. Once we have diagrams like this, analysts work through the diagrams to try to identify specific elements that speak to the policy question that's being posed to us. But we're calling out here the different snow and ice observation key products and services, and how those contribute to multiple SBAs, including transportation, climate, weather, and so on. And playing to, I think, the last question from the previous talk, what are the next steps? Well, very often we're getting asked now, this is great. Let's stand on those shoulders and say, what about all of the non-federal users? What about all of the non-federal sources of data? It's yet another heavy lift to get all of that integrated and to be thinking about all of that in a coordinated way. But it's the next natural step now that you've got this platform to work from, to both refresh what you have so that it stays current and it stays useful in policy discussions, but also to add on to it and add non-federal resources. And yes, you run into Paperwork Reduction Act kinds of concerns once you start talking to non-governmental users of these systems and providers of data. So some simple logistical barriers to be run through there. We need the willpower to be able to make all of those things happen. And I will end there. Thanks.
Do we have any questions for Will?
For many of you, I expect this is old hat. We've been talking about this since it was originally done in 2016. So,
so I have a question.
Yeah.
So in one of those slides, you had sub areas and areas, for instance.
Yes.
And I think you also had KPSOs and KPSO groups. Did you actually model the sort of aggregates as their own node, or did you essentially layer that hierarchy on afterwards? Because it doesn't seem to be in quite the same category as the links between the products and the actual SBA.
Right. So if one were to look at the EOA dataset proper, there are a lot of administrative artifacts that have been layered in there to handle things like systems with multiple naming conventions, systems that got mentioned by different users but referred to in different ways, or they meant different levels or different instruments on a platform kind of thing. So the simplification of the original 150,000 rows down to a manageable graph database size was in part about collapsing some of those straight line connections through the graph. And some of the artifacts that come out of that are, well, all of this layer of observing systems are actually feeding these aggregated data sets. And so we started to find some interesting, counterintuitive connections in the data set. So our classic example that we pull up is there was a stream gauge in the Nevada area informing Alaska wildlife reports, right? And it's because all of the stream gauge data gets aggregated into a single data set. And when people talk about being dependent on that data set, they don't typically talk about which aspects of the data set they're dependent upon. So capturing those interconnections at a finer level of resolution would help to disaggregate that. But for the moment, there are some of these catch-all categories to try to bring those things together and bring harmony to it.
Okay. I'm wondering, do you run into anything like that in self-serve, that kind of issue where an aggregation of things has generated counterintuitive results, or rather an individual? Not really.
Not specifically,
Okay.
no.
All right.
Any other questions?
Thank you.
All right, so we have another 20 minutes or so. So I wanted to do a little bit of working in the session. And let's bring up our. Okay, so talk about the way forward. I guess my first question is, I gave you this heads up. So my first question is, are there any additional use cases that come to mind as these talks were given that we could add into the suite of use cases? So we had some use cases that were basically discovery-based. We had a couple of use cases that were policy-based. We had some technologies that actually help solve the overall construction problem. Did any of that suggest any additional use cases that we haven't? Yes. And Doug, could you take notes on this? Thanks.
Well, I'll just summarize. We had a workshop, and I'll also defer more to Tyler and another colleague, Eugene Berger. We had a workshop in November working along very similar lines, looking at cross-agency usage of data sets, identifying how that links out to research and then policy implications. And we have an effort, knowledge graph effort, to build that out, document that. Two of the big use cases there are, number one, can we connect out with the community of users and get feedback about how to improve the data sets or if there's any problems? And then number two is, what can we provide at point of usage? Particularly for the kind of cases that our team is looking at is more where there may be sensitive data, federal data that's sensitive and has to be used on certain platforms, but yet it needs to be joined with spatial data to identify the use cases. So at that point, could there be recommenders or other services provided for analysts or helping train new analysts too?
All right, thank you. I see we've got John up there and Jeff over here.
Sorry, could you raise your hands again? I didn't
John.
see who.
Yeah, I was thinking that here at NCEI, we have lots and lots of small data sets going back many, many, many years with varying degrees of metadata. And turning that catalog into a graph might help identify subsets. Common collections might help identify areas where we could do a better job with some small efforts to improve the metadata for those outliers, where we could find duplicate data sets that we didn't even know we had, link them together. Of course, then there's the recommenders, the external customer data discovery, but I was thinking more internal management and improvements.
That's interesting. Yeah, that's interesting. I think we probably have some data centers within EOSDIS that might benefit in a similar way.
Yeah, so I'm also wondering if, some of the stuff Doug was talking about is, understanding, recommendation engines and things like that. But I wonder if we can combine a lot of that information with some of the metrics we collect to really kind of surgically understand who's using what and kind of how they're using it to help improve provision of services, or, you know, reach out to, you know, help users in particular sectors maybe understand how they might use the data a little bit better or improve that kind of outreach.
Right. So that actually says something in common with the first couple of use cases where we're actually using it to get out to users to improve the systems.
Just a follow up to the previous two comments. In fact, it's great to see all these graphs, and it could be very useful for help us discovering data and understanding who's in the community. Let's go one step further. If we could have a complete set of graph of all those, so how to come up with that complete set of graph? Do we have some kind of automatic extraction capabilities, machine learning, or other that could help us?
So actually, one of the talks, the talk that unfortunately couldn't be given because Lewis had to leave early, was actually looking at some technologies to make that graph construction a bit easier.
This room is terrible. Okay, so Kirsty from USGS. It struck me about the societal benefit areas in particular. We've been collecting statistics for over 10 years now at Arrows on the usage areas that our users download data for. So it's all based on user demand. And in particular, I work Landsat, so that's a lot of our downloads. And the interesting thing is we have most of the societal benefit areas covered, but we also have about twice as many more areas. And I think this last presentation touched a little bit on those societal benefit areas really are about government usage, but we have things that we track that are things like urban sprawl and urban development, transportation, real estate, insurance industry. So I think there's a big missing chunk of user need that isn't captured by those. And I think that's the one thing that's why I was going to ask the question before is, you know, how do you capture those areas? Because there's a large user community. We always talk about the Landsat user base being a mile wide and an inch deep. And a lot of it is government use, but a lot of it isn't. So.
Right, and actually some of that I have seen in the Sustainable Development Goals from the UN, but what that doesn't cover, and which we've alluded to briefly here, is just pure economic usage of the data. You know, the hardware company that's, you know, moving snow shovels to where the snow is expected to fall, that sort of thing. And I have to admit, I do not know where to get that information. But if there's any place that can sort of help us find out where to get that information, I think it's probably ESIP, at least as a starting point.
This is Tyler from NOAA. The project that Paco was alluding to, one of the ways that we're trying to get at other uses outside of the federal sphere is by publications, peer-reviewed publications in journals, and trying to tease out which data sets are used by which publications, which is always tough. You know, if there isn't a DOI or if people haven't used the DOI, then it's really hard. But they're trying to use some machine learning techniques, some natural language processing to tease out, if you have a full text of a journal article, to tease out which data set was used, and then try to, and of course, you don't use exactly the same words or exactly the same.
Right,
so which ones are actually similar and which ones?
Yeah. So we've taken a swing at that problem like 5 different times over the last 20 years, and we never quite get it right.
We're up to about 80% accuracy.
Oh, good. That's good.
The other thing is to go to the authors and get confirmation.
Right.
So the human in the loop aspect of going out to author communities, depending on what scientific area.
Right.
But ResearchGate is really interested in working on this, and some others.
I just also wanted to mention that this is a current project we're looking at, is looking at the DOIs in different publications, the unique records for different NOAA products and other services. and using those, looking through different databases, journal publications, and seeing how our products are being used. This, yeah, bibliometric mapping is another way to look at it. And I think AAG also does a lot of work talking about different views of societal benefit areas, more from other uses outside the civil agency needs.
George.
With respect to use cases for spatial, the joint spatial data on the web working group of OGC and W3C is going to be providing use cases and input to the GQL standard that Doug mentioned. And so we're collecting use cases and example queries on property graphs that have spatial relevance. You saw one here today in Selfie, which is kind of the ecosystem kind of thing. There's the one that's typically kind of a transport or network graph. So doing your navigation from here to home, you know, is all a topology calculation with weights that have to do with time and that kind of stuff. The third one is that we've identified is events and activities. So people doing things at certain times and how do they relate to each other in terms of activities for a variety of social, intel, and other reasons and the like. And so if there are additional use cases coming from this community with respect to property graphs for spatial queries, I'd be very interested.
Mm-hmm. And I have to say, I hadn't really thought about the spatial aspect until I saw Dave's talk today, which is ironic because, you know, I saw it first at OGC. But now I think I want to go back and think about that spatial aspect with respect to some of the NASA use cases. Yeah, because I admit I had a global blind spot, right? I think of everything as global because most of our data covers the entire globe. Go figure. Bill?
So, Chris, I want to key on the comment about the SDGs, which is what we've been working on at GEO and elsewhere. A very applied kind of look at this is to figure out how you can put these mechanisms together so that they can be useful to the statistical community, to the national statistical offices globally. There's a lot of question about how we're going to use advanced Earth observations to support the SDGs, with a great deal of reluctance from national statistical offices to take up those capabilities because they don't have the pedigree and provenance that they're used to in standard statistical practice. If that can be augmented using these technologies to provide the links necessary to provide basically the veracity for the data, that would be very, very helpful. I'd invite everybody to look at the UN Statistical Council's background documents and agenda for early March, and you'll see a lot of opportunities where this kind of thing could be brought to that group's attention. Thanks.
Okay, thank you. Interesting. Yeah, I did not see that coming. All right, so now, unless there's any last burning use cases, I want to get to the last. I'm going to make this the last part of this session, which is how to move forward. So typically, the most common way that we attack this sort of project in ESIP is through a cluster. In fact, usually we'll start as a cluster. Occasionally that will graduate to a committee or a working group, something like that. And so I went to the collaboration area to look at all the clusters to see, is there an existing cluster in which we should be doing this work? Or should there be a new cluster? Or some other mechanism. Well, like I said, usually, you know, we tend to go with the cluster mechanism. And looking through this, I was reminded of one of my old favorites, the Discovery Cluster, which I think we started back in 2009 or so. But it's been kind of dormant for the past few years because we sort of solved the problem we started up to solve. However, since, you know, several of the use cases we've talked about are discovery use cases, that's one possibility, is to essentially revive the Discovery Cluster around this general problem, but also make sure that it includes these other use cases as well. So that's one possibility. Other possibilities might be, obviously we would probably need some help from the Semantic Harmonization Cluster. Isn't there a geosemantics cluster? I didn't seem to find that one. And then of course we could start a new cluster. Let's call it the knowledge graph cluster or the documenting data matter cluster. Yes. Yes, I forgot about that. Data to decisions for climate resilience. So might be a little limited for the set of use cases that we've talked about here, but it does point out that whatever cluster we do this work in, it's probably going to be extremely useful, if not mandatory, to go out to the other clusters to get this kind of information, because a lot of those other clusters are doing some aspect of this. You know, how do we use the data? Any other thoughts on clusterization? It's not that bad. I mean, you basically start up a new web page and, you know, with the little quadrant thing. I think we put together like a one-page little description of what the cluster is going to do. So Doug Newman is suggesting we start a new cluster. I'll tell you what, let's take a quick straw poll on start a new cluster versus use an existing cluster. And it can be the existing cluster of your choice, at least at this point. If that wins, then we'll have to, you know, zero in on what the existing cluster is. So who thinks this would best be done by starting a new cluster? Please raise your hand. Okay, what are we talking here? All right. All right, now, who thinks we should be using an existing cluster? Okay, so I think we're, okay, let's have another idea.
So you said that the discovery cluster is kind of on hiatus. Could you maybe recharter/rename the discovery cluster? Because this is very topical to discovery.
Right.
And it's, anyways, I just, the sprawl of groups does come along with some overhead, and it gets a little bit ugly.
Yeah, that is true.
So.
Well, we can position the retirement of discovery cluster at the same time. My concern, as Chris mentioned earlier, the inclusiveness of it. Say discovery, some people might be put off that don't need to be put off.
Yeah, recharter and potentially rename this.
Yeah, I think we could probably do that. I mean, clusters are kind of loosey-goosey anyway, so. So I think what we might do is archive the existing, you know, content essentially, and essentially start anew. Who's
in favor of doing that? Rebranding discovery.
Yeah, I think that's our winner. Let's make a note of that. And I think in just the last couple of minutes, are there any further thoughts anybody wants to add? You know, I think we'll probably do that through email.
John Ralph at NCEI again. Yeah, I was thinking about we were talking about locations, named locations, resolving locations, landing pages, whatever it is. And it seems that you could just as easily extend that to time periods, eras, epochs, etc. Especially when we're talking about, you know, cores looking down into the past.
Right. All right, and I think with that, I'm going to give you 5 minutes back. So I want to thank everybody for participating. This has been extremely helpful. Thank you.